welcome to another episode of Let's Make It. This is episode number 57, and it's recorded on April 21st of 2014, the day after Easter in 2014. And this week, I am back with my co-host, Bob. How's it going, Bob?
It's going good. How are you?
We seemed to miss each other last week, but that's okay. Things happen like that, so...
I was just a little late getting back home last Monday. I'm sorry.
That's okay. The 3 weeks before that were kind of a mess for me, so we had to skip those 3 weeks. I still went ahead and put it out there because I wanted people to know that we weren't dead or anything, you know?
Yeah, that's right. We weren't dead. We have been doing things in the background.
Yeah, it's been very busy. Now that Easter's over, though, that was kind of my target date for some things I was working on, so... Now that's passed, it should be letting up. Actually, today felt a lot better. It felt more like normal to me today. So hopefully things will get back to regular schedule here.
Well, that's good. Unfortunately, I'm the other way. I seem to be getting further and further behind on everything I work on. So. Well,
that could happen to me too, but for right now, my goal was Easter. So now I'm like relaxed a little bit better, a little bit more relaxed.
That's good.
So last week we were going to talk about some logic gates, and you're going to do that this week. And you're also going to revisit something we did back in episode 6 with a sensor.
Yes, and we for folks watching, Mike just told me that he covered this in episode 6, and I was asked about it a couple weeks ago, and then came across got a hold of a sensor, and just whipped up a little code, so we'll revisit it again. So
we'll get to that here in a second. How much did you do with RF, Bob?
I have done bits here and there over my career.
So I kind of mentioned this last week in the show. I've been playing with some software-defined radio, which is like it's a little $19 USB stick that allows you to define radio and bring all the tools to bring it in. And I've been playing with it a lot the last week, a lot in my spare time with the load that I had. But it's kind of neat, so I think I might start covering that. It's not necessarily electronics per se, but I think it's still a neat thing. You can figure out how you can listen to FM radio or ham radio all on your laptop. In fact, I have a little thing right now that's tracking airplanes. All airplanes, commercial airlines, have this thing in them now. By 2020, they'll have to have it. But most of them have it now. It gives their altitude, their destination, the direction, and their location, and it keeps transmitting it out once a second. So it's kind of neat. You can kind of watch the airplanes that are around you.
Yeah, that does. Well, it is electronic, and it is an electronic gadget, and we do cover gadgets.
Yeah, so in the next couple weeks, I'm going to start putting together some...
I think it's fair game.
Yeah, so I'm going to put together a couple probably going to do them separate episodes, and we'll just play them during the show, because there's lots of room for things to go wrong with that stuff. So...
Yes, you're right. There is lots of...
Yeah, especially as I'm still learning it. It's just one of those things that interests me, because in the pulling things out of the air that's free and figuring out what's going on is very interesting, I think. And the software, some of the software is very neat too, because it decodes some of the data that's in the air.
Ah, okay.
So yeah, it's kind of neat. I'm going to work on a couple different episodes, talk about different things, but I think we're going to start covering it a little bit. It is a little side project for us.
Side project, okay.
Yeah. So I'm going to hand it over to you and let you take over and do your little logic gate. Right. Are you ready for that?
Yep.
Or ready as you're ever going to be?
Yep. Ready as I'll ever be. Let me switch over to my desktop. All right. We should be looking at the desktop now.
Yeah, I see a Wikipedia page.
Yep. Well, I started looking at that. And we talked about logic gates at the end of which episode was it? It was
I think 54.
Yeah, and logic gates are one of those things. It's like shift registers or 555 timers or lots of little components. You kind of, if you know that it's there, then it's really good to have in your arsenal of goodies to work with when you're working on a project. But logic gates, basically it's a generic term for what are called ORs and ANDs and XORs and a whole family of Boolean functions, and it's all based on zeros and ones. And this Wikipedia page, I'm not gonna go through this whole thing. It's actually a real good read, but I'm just gonna hit the highlights of it because I'm I'm not going to be insulting to the intelligence of people who watch this show. They can read just as well as I can, but I do want to point out a few things that basically there's and I've got a demo of a couple of these chips, and they're very simple. They're very easy to use, um, but there's several of them, and basically let's just start with the first one. This what's called an and an AND gate is exactly what it sounds like. If the two inputs, if A is on and B is on, then the output is on. But in this truth, and these are in this right column, everything is called the truth table, and it defines, it gives you a visual for what the output is going to be. But for an AND, if both inputs aren't high, then you get nothing. If both inputs are high, then you get an output. An OR, it does exactly what you'd think it would be. If one or the other input is high, then you get an output. Or if both are high, you get an output. And a NOT, I kind of disagree with this. A NOT really isn't a logic. To me, it's not a logic. It's just an inverter. But it is here. Lots of people call it, think of it as a logic circuit, but I just think of it as an inverter. I guess that's the way I learned it in school. So, and then you have, this is where sometimes people get in trouble. A NAND is nothing but the opposite of an AND. So whatever your output, if you look at the way your output is for an AND, it's reversed for an AND. Does that, hopefully I'm making sense here.
Yeah, so basically it's like adding an inverter to the end of the AND box.
Essentially, yeah. That's one way of looking at it. I kind of look at it as input, but you're right. It's sticking an inverter onto the output. NOR is the same way, not an OR. XOR is a little different in that it's you get an output if the input is different. So if both inputs are high or both inputs are low, then you get nothing. If one or the other is high and they're different, then you get an output. And then an XNOR is kind of is the same. It's just the reverse of an XOR. So these are, they're good little tools to have in your arsenal. And I picked up one other Wikipedia page that I wanted to show. And that's somebody put together, and I can't imagine all the work that went into this, but somebody put together this list of all the 7,400 ICs. So for any input, for whatever project you have, there's bound to be there's a chip for it. So quad input NAND gates, single input NAND gates, every one of them is here. And of course, all of these have different voltages, different settings, different inputs. And so for somebody who needs a particular, little IC, they're all right here. They're all documented for us. So let me switch back.
That was a lot of work by somebody.
That was a lot of work by somebody. Wasn't me. So here in my little demo, and I actually have several things in here, and I guess I knocked the camera without realizing, and I knocked the camera, and everything is now a little crooked. But these are just to show how simple. Let's move this off of here. This is using one of these chips is as easy as turning on and off pins. Now in the real world, you probably wouldn't be you wouldn't be using an Arduino pin like this. I just wanted to show that how easy they are to turn on and off, and get an output. And get the output that you expect. And essentially, when both pins are high, you get the LED comes on. When one of them goes low, then of course they do just what they're supposed to do. If both are high, you get an output. If one or the other or both are low, then you don't get an output. But you could use these circuits to, I was thinking about it. When would you use an AND? Well, you might use an AND circuit if you want to turn on a relay, but you also have some sort of safety switch. So if the safety switch isn't set, and the safety switch would prevent you from turning on a relay or turning something on. There's so many places you can use these that I'm actually lost for.
Yeah, but that's actually a very good one, because you would use that like a key of some kind that would like protect you from doing something wrong. So, or it's you want to make sure you have somebody pushing the button so their short's going to go on before, that way the automation doesn't do it when it's not supposed to.
That's right. Yeah. So it's one of many, and then I put together this little sketch, more than anything, just to, just to show off a little bit that you can turn things on and off, and I see that there is a slight delay. The terminal window is getting things in real time, but there's a slight delay in the camera output. So,
okay.
So the scrolling text is a little off from the camera.
Yeah.
Oops. But there's lots of places that you can use this. And then I also have a NOR that this first IC right here is the AND chip, and this is no, that's the NOR. Here, this is the AND. So it has 4 inputs, or 8 inputs and 4 outputs, voltage and ground, in a single package.
So this is a 4 AND chip.
This is a 4 2-input AND gate. And actually, I've got the wrong, I'm sorry. There's the AND. Okay, 4 input, or 2 input AND gates, and 4 of them all in one package. So makes for a very convenient package. And then let me go. So here's what the logic diagram actually looks like.
Okay.
So you get different. You can turn them on and off all you want. And here is the NOR that I have which is the second chip that you see. And here's its logic diagram. And for it, I have this little sketch, which will load up. And now it's turning on and off its lights, just as the pins go high and low. Now, this actually does show, and I had to go look this up. You see how these two lights on the AND are still on?
Yes.
That's because the Arduino has floating pins. So
Okay.
the AND gate, so those ANDs are reading that voltage that's in there. It's not a full 5 volts, but it's not zero either.
It's enough to. It's just enough probably to turn it on then.
It's just enough to turn it on. Where the NOR gates, they're looking for full voltage, so a floating gate won't turn them on. But they're very easy to use, and there's a multitude of places where you can use these. And one of them that we talked about at the end of the last episode was actually, this is I went and looked up this chip. This is a 4-input OR gate. So we were talking about the street light.
Uh-huh.
And you could have different states that would turn on different combinations of the red and green and yellow lights. Well, this is how you would do it. So depending on which state you're in a decade counter, you could use this to turn on the right set of lights at any given time.
Yeah, so you'd use multiple of these. One for, like, you'd have the decade counter go through like 10 steps or whatever it is for all the lights, and then you'd have the ORs attached to whichever ones it needed to be on for.
That's right. So for somebody to do, and I was actually thinking about this because one of our viewers sent in a picture. He's got an antique street lamp that had, the old style where it's all the lights are in one unit.
Yes.
And it sits in the middle of the street. He's got an antique one of those, and with a 555 timer, a decade counter, and a couple of these OR gates, he would have a working street light and he'd use $5 worth of components.
Right.
And that's all it would take. So
yeah, it's probably worth mentioning that these types of chips are very inexpensive.
Oh yeah. Those two chips right there, I don't think either one of them were $1. So they're very inexpensive, easy to use, and very reliable. I mean, you really can't, other than blowing them up with too much current, you really can't screw them up.
Yeah, right.
But they, like any other component, they do have specs on how much current you can have and what voltage is, and so they're, for whatever application, you're bound to find the right chip out there somewhere. So there's logic gates. They're easy to use, and it's not, once you start looking at these truth tables, it's very easy to find the exact component that you're going to need to do what you want.
Right.
So that's it for that's what I had for logic gates tonight.
Okay. And then you had mentioned that you also looked at the other sensor. Do you want to go through that real quick as well? Okay.
Sure. All right. I guess I should have stayed on my desktop. Sorry.
That's okay.
Let's see. Okay, video. There. Skype and I are not one. So,
I don't think Skype is one with anybody.
Yeah. That's a whole nother story. So
that's a whole other show.
A whole nother show. So this is what this was a viewer question that I got asked about. And I didn't realize that you had done a show on this already, so I'm sorry about that.
No, that's okay. I'm not sure it's exactly the same. It looks a little bit different than what mine did.
Well, it's a little ultrasonic sensor. I think they're $6 or something on Amazon. $6 or $7. They're very inexpensive. The reading this data sheet, it is a little. Yeah, if you don't have some scientific background, some science in your background, then some of this doesn't make a lot of sense. But if you look right here in the background, I have this unit facing away. And let me load up.
So it's on the back side of the breadboard?
Yeah, yeah.
Okay.
You're looking at the back of it right here.
Oh, okay. It's over there, yeah.
If I turn this up, you can see the little.
Yep, there. You can see it real good there.
Cylindrical two front pieces on it. So this is so in this sketch, I've got some code for the serial monitor. But essentially, this is a very easy unit to use. It's got 4 pins, voltage, ground, and then a trigger pin and an echo pin. And what you do is you turn on your trigger pin, and this is actually not right. The trigger pin has to be on for at least 10 microseconds for the unit to work. However, I found that it would occasionally give you a 0 if you didn't. It's a minimum of 10 microseconds. So I found that if you changed it to here to 11 microseconds, that you got better results in the code. So you turn on the trigger, 10 microseconds minimum, turn that trigger pin off, and then wait for the pulse coming back in. And this echo pulse is essentially the distance. And the formula that you get out of the data sheet is you take whatever that duration is in milliseconds, divide it by 58, and you get centimeters. Or you can divide it by 148 and get inches. So I could easily switch. I'll just do this. So we'll change it to inches. And we'll change this. And serial monitor. There it is. And it's checking and that's about the right distance. So if I stick my hand in here, it does change its value. So it's reading correctly. When I was testing this, it did seem like it was about half a centimeter off.
So what's the maximum distance you could get? Do you try a maximum on it?
According to the data sheet, it's 4 meters.
That's what mine said too, and I couldn't get 4 meters out of it.
I was actually able to get 5.
Oh, really?
Yeah.
Well, I don't know. I mean, that was before I had the walls in here. I had all the foam, and I wonder if that was part of the mess. Maybe it was absorbing the sound.
Possibly. I was using real walls, and I could get 5. Past that, it got real dicey. Sometimes it would find something off in the distance, and sometimes it wouldn't. I suspect that it's just not putting out a strong enough signal to go any further than that.
Right.
But it's a nice, simple, inexpensive, easy to use sensor. So I actually have a little project that I'm working on right now with this guy. So that'll be in a future episode.
Okay, good.
So that's what I have for tonight.
All right. So before we go, let's talk about a couple of things that out in the Google Plus community. I saw Jim put out there. You and him have been working on the TV out thing.
Arduino TV. Yes,
yeah.
we have. And
he sent that image out. That's impressive. I hadn't had a chance to look through any of it in great detail, so over the next couple of days, I'm going to go back out there and look at that. But that's really neat to be able to do TV out from an Arduino.
Yes, it is. It is a little basic, which you'd expect, given what an Arduino technically can do.
Right.
One would expect that. But yeah, the TV out that he's got is looking pretty good now. So
yeah,
he sent me this code, and I kind of read through it, and his code was well documented and well written, and even though I'm not familiar with those libraries, it was easy to follow along. So he's done a nice job with that. So
yeah, that was really impressive. So if you haven't been in the Google Host community, go out and check it out, because he's putting it out there, and that's very helpful to everybody else too.
Right.
So and he's in the chat room tonight with us here too. So
yeah,
definitely appreciate that. That was kind of neat. I mean, it reminds me a lot of like the old style video games with the big fonts, but the fact that you can even do it, to me, is impressive.
Yes, yeah, it did remind me of the '80s video games.
Yeah. Yep. So that's very neat. And I think if I remember right, it was a scoreboard I think he had up there, right? Like home and visitor or something like that.
Yeah, so he's got a scoreboard with a keypad attached to it. And it's kind of reminiscent of a show we did a while back with the controlling two radios. That was the genesis of that demonstration, was someone wanting to control a scoreboard remotely. So,
right, exactly.
So here he's got a TV being controlled by a little keypad and Arduino. So
yeah, that's pretty cool.
Pretty impressive.
Yep. Yeah, Jim figured that on his own for the most part, didn't he?
Pretty much, yeah.
That's good.
He's done most of it. I've offered to help, but he sure hasn't needed much.
It's nice to have other tinkerers out there like that.
That's right. So, all right, that's what I have for tonight.
Okay, well, that's pretty much all I have too. Just a few things before everybody go. Just remember that you can follow us on YouTube, and you can download our stuff from pretty much any of the podcast directories. And if you find one where we're not, please let us know, and I'll get it out there. We're also, you can watch us on Roku. We have a Roku app, and if you still have a TiVo is becoming popular again, I think. We are on TiVo as well, so you can watch the show and all of our shows on the network on TiVo or on Roku. Again, you can download us all from iTunes or Dogcatcher or any of the other podcasting directories. And please tell a friend. That's how we're growing, and we're actually growing. I was amazed at how many downloads we had during these 2 weeks that we weren't even on, Bob. I recently went to a different tracking system, and I got here, I guess it was Sunday night. I was looking at it and thinking, like, look at all the downloads we've had. And we didn't even do a show. It's pretty crazy, actually. That was,
Well, and we're getting viewer responses. I've had several about the GPS unit that we did a month ago, and I'm getting questions every week about that.
Yeah, so it's definitely, the community is growing. And so we have a Google Plus community. So if you go to tech-send.tv and click on community, you can go out. For show notes for this show, contacts, and more, go to the techsend.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techsend.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.